Want to give your AI models or client apps clear hints about how they should interact with your resources? You'll see how to use FastMCP's annotation system to mark resources as read-only or idempotent, helping clients optimize their usage patterns. This simple metadata can prevent misuse, improve caching, and make your resources more predictable for consumers.
At MCP, resource, data//config, annotations equals, read-only hint, true, idempotent hint, true, def get config, dict, get application configuration, return version, 1 debug, false.
This demonstrates the resource provider pattern for exposing structured data through declarative endpoints. The @MCP resource decorator transforms Python functions into addressable data sources, creating a clean separation between data access logic and the mechanism that exposes it. What makes this distinctive is how it turns ordinary functions into self-describing data services with minimal boilerplate. The pattern works by treating the decorator as a contract that defines both the data's location via URI and its behavior through annotations. FastMCP handles the discovery, serialization, and delivery automatically, while your function remains focused solely on producing the data. This declarative approach means you define what data is available rather than how it's accessed, enabling the framework to optimize delivery based on client needs. This approach solves the common problem of exposing backend data to diverse clients without tight coupling. It's particularly valuable when building systems where configuration, status information, or dynamic content needs to be accessible to both traditional clients and AI agents. The trade-off is that you sacrifice some low-level control over transport details, but gain significant simplicity and maintainability for most use cases. Let's break it down line by line.
At MCP, resource, data//config.
This registers the function as a FastMCP resource at the data//config endpoint. Resources are read-only data providers, unlike tools which perform actions, making this pattern ideal for configuration or metadata exposure.
Annotations equals.
The Annotations dictionary attaches metadata to the MCP resource, enabling tooling and clients to understand its behavior without runtime checks. These hints inform the MCP framework how to handle this endpoint, like marking it as read-only or idempotent for safe caching. This is the standard pattern for declaring resource characteristics in FastMCP.
Read-only hint, true.
This is a FastMCP resource annotation that signals clients this endpoint is read-only. It prevents accidental modification attempts, enforcing safe consumption of configuration data.
Idempotent hint, true.
This marks the endpoint as idempotent, guaranteeing identical results for repeated identical requests. Critical for configuration, endpoints where clients may retry operations, preventing accidental state changes from duplicate calls. FastMCP uses this hint to optimize caching and retry behavior. This closing brace terminates the Annotations dictionary, finalizing the metadata for this resource. The annotations configure FastMCP's behavior, here marking the config as read-only and idempotent to prevent unintended modifications. This closing parenthesis terminates the @MCP resource decorator declaration, finalizing the configuration for this endpoint. It marks where the decorator's metadata, like read-only hint and idempotent hint, ends and the function definition begins.
Def get config, dict.
This defines the configuration endpoint function with a return type annotation. The dict declaration enforces that this function must return a dictionary, enabling static type checking and IDE support. This is standard Python type hinting for better code reliability.
Get application configuration.
This docstring defines the tool's purpose for AI models and human developers. FastMCP uses it to generate API documentation and tool descriptions, while IDEs display it as hover help.
Return version 1 debug false.
This returns a hard-coded configuration dictionary with version and debug settings. The read-only resource decorator above ensures this acts as a static configuration endpoint, preventing modifications while allowing consistent access across the application. FastMCP resource templates. URI templates transform static functions into dynamic resource factories, where a single Python function can materialize infinite endpoints through parameterized paths. The wildcard parameter syntax, param, silently consumes all remaining path segments, which can accidentally mask routing errors if overused. Always validate wildcard inputs, since they bypass the usual single-segment type safety.
The resource that never exists serves every request.